When you think about a ride-hailing app, what comes to mind? You probably picture a pretty standard setup, right? You tap a button, a car shows up. Simple. But what happens when you try to launch that same tech in a place with a totally different culture, a different economy, and even different kinds of traffic? Well, it turns out that building a global product is definitely not a one-size-fits-all deal. So let's dive in and see how engineers crack the code on building a ride-hailing app specifically for Sri Lanka.
All right, take a look at this number, 53%. Any guesses what that is? It's the percentage of all ride-hailing trips in Sri Lanka that are taken, get this, in three-wheelers, tuk-tuks. I mean, right away, you know this is a whole different ballgame. That single statistic changes literally everything about how you have to design and build the entire system from the ground up.
And that brings us right to our first huge challenge. You have to understand the completely unique transportation landscape of Sri Lanka. It's a puzzle that goes way, way beyond just cars and maps.
So as we just saw, three-wheelers are king of the road, and motorbikes are right behind them, making up another 21% of rides. What this tells us is that users there really value high agility, low-cost ways to get around. But this isn't just a cultural thing. It's a massive engineering problem. Instead of tracking a few thousand cars, the system has to handle tens of thousands of these smaller, faster vehicles zipping through incredibly dense city streets. The sheer volume of data is just enormous, and it all has to be processed in real time.
Oh, okay. The next piece of this puzzle is fascinating. It's all about what users actually want to see on their screens. And this brings us to a really interesting clash of design cultures, a kind of battle between what feels clean and what feels trustworthy.
On one side, you have that classic Silicon Valley minimalism we see in apps like Uber. The goal is pure efficiency. Get a ride in like 3 taps. It only shows you what you absolutely need to know. But in Sri Lanka, the local favorite app PickMe goes for what you might call maximalism. It puts a ton of information right there on the screen, and this comes from the region's digital history, where popular websites were always really information-dense. So for a lot of users, seeing more information feels more transparent, more honest.
And this, right here, is the core insight. What an engineer in California might see as a cluttered, confusing screen, a user in Colombo sees as a sign of trustworthiness and transparency. The design has to reflect what the local definition of a good experience is, and in this case, that means showing your work.
So you've got thousands of tuk-tuks flying around, and users who actually prefer to see a lot of data. How in the world do you build a system that can handle all of that? Let's get into the technical blueprint and see how it's done.
The answer is something called a microservices architecture. And you know what? That pit crew analogy is perfect. Instead of having one giant, clunky application that tries to do everything at once, you build a whole collection of small, independent services. Each one has a very specific job, and they all work together like a perfectly oiled machine. So when you tap that Request Ride button, it kicks off this whole cascade of events. Your phone talks to a dispatch engine, which is basically the matchmaker. At the exact same time, a pricing engine is calculating the fare. Databases are logging all the trip details, and a message broker sends out notifications to both you and the driver. Every single step is handled by its own little specialist service.
And the real beauty of this approach is that you can use the absolute best tool for each specific job. You can see the system uses different technologies for different things. One that's great at handling thousands of real-time connections with drivers, and a completely different one that's perfect for running complex machine learning models for the pricing. This flexibility is what makes the whole system so fast, so powerful, and so much easier to scale up.
Okay, now we get to the really exciting part. This is where we see how that powerful, flexible tech is used to solve those very specific local problems we talked about. Everything from fairness and pricing to just finding your front door.
Let's start with a big one. Can an algorithm be unfair? The answer is absolutely 100% yes. If you're not careful, a dynamic pricing system could just learn to consistently charge people in lower-income neighborhoods more, all based on historical data. That's a huge problem.
So to prevent this, the engineers used a mathematical tool called Jane's Index. Now, you don't need to be a math whiz to get this. The formula you're seeing is basically just a standard way to measure inequality. It looks at all the prices across the city and spits out a single fairness score. It's kind of like a Gini coefficient, but for ride prices instead of income.
And here's the key. They set a concrete goal for their system. It has to maintain a fairness score of 0.85 or higher. By building this check directly into the pricing algorithm, they took an abstract ethical problem and turned it into a solvable engineering target.
Here is another absolutely brilliant local solution. What do you do in a place where street addresses can be confusing or sometimes don't even exist? Well, you integrate a system called What 3 Words. It divides the entire planet into 3-meter squares and gives each one a unique 3-word address. So your destination is no longer somewhere down that alley, it's precisely filled.count.soap. Genius!
This tech can also drive some serious social change. Research showed that safety concerns are a major reason why many women don't use ride-hailing services. And just look at the economic impact of that. Closing this gender gap in ridership could boost annual revenue by over 25%. This makes safety not just a moral issue, but a major business priority.
So what did they do? They built safety directly into the app's code. Features like an SOS toolkit that instantly shares your location with emergency services, automatic notifications to trusted contacts, and even number masking to protect privacy. They all work together to build the trust that's needed to make the platform feel safe and accessible for everybody.
So as we zoom out, it becomes crystal clear that this was never just about building an app. The real goal was to build an entire ecosystem that was deeply in tune with the social, cultural, and economic realities of Sri Lanka.
This quote from the research paper that inspired this whole explainer just says it all. The goal was to create a system that is not only technologically advanced, but also socially responsible and culturally resonant. That was the real engineering challenge all along.
And that leaves us with one last question to think about. Is the best technology just the one with the most power or the fastest speeds? Or is it the one that's the most thoughtful, the one that's designed to meet the real needs of real people in their own communities? I think the story of this app in Sri Lanka gives us a pretty clear answer.